The idea of a chi-square test for independence. Chi-square tests for independence are used when you have two qualitative variables, that is, variables with two or more categorical outcomes, and you want to see if they influence, have an effect, or are related to each other. The null hypothesis is that the two variables are not related, that is, that they are independent. The basic idea of a test for independence is to compare observed sample data in various categories to what you would expect the data to look like if the two variables were not related. Let's consider an example. Suppose our two variables are age group, either young, middle, or older customers, and bill payment preference to either pay bills online or mail written checks. We want to know if age group affects bill payment preference. The null hypothesis is that it does not affect it, or that the preference is independent of age group. Suppose we take a sample of 500 customers, 200 young, 200 middle, and 100 older customers. If preference really is independent of age, that is, the null is true, then we would expect that the same percentage of people in each age group would prefer to pay bills online. For example, if the overall sample of 500 customers yielded 350 or 70% of people who preferred to pay online, then if bill pay preference is independent of age group, we would expect 70% of people in the young age group, 70% of people in the middle age group, and 70% of people in the older age group to prefer to pay online. For the young and middle age categories in which 200 people were sampled, we would expect 70% of 200, that is 140 people, to pay online, and 30% of 200, that is 60 people, to mail written checks. For the older age group, we expect 70% of the 100 people sampled, that is 70 people, to pay online, with the remaining 30 to mail written checks. These are called expected frequencies. The idea of a test for independence is then to compare how far away the actual observed frequencies are from what these expected frequencies are. Of course, some variation from these expected frequencies is anticipated due to sampling error. But if the observed values are too far away statistically speaking from what we expect, then we have evidence that the null hypothesis is not true. That is, that the two variables are not independent.